Have you ever looked up at the night sky and wondered what else could be out there? With our heads tilted upwards, we're peering into the vast expanse of space, a cosmos filled with enigma and potential. It's a frontier that extends beyond our wildest imaginations. Could we be alone in this vast universe? Or is there life beyond Earth, hidden in the corners of galaxies far, far away? Let's dive into 10 intriguing facts about space and the potential for extraterrestrial life. First, let's try to grasp the sheer size of space. It's so vast, it's almost beyond human comprehension. Picture this. Our home, the Milky Way, is just one of an estimated 2 trillion galaxies in the universe. Each of these galaxies is teeming with stars, around 100 billion on average. Now here's where things get even more mind-boggling. Each of these stars could potentially have a family of planets orbiting around them, just like our own solar system. The numbers are staggering, aren't they? But let's not get lost in the numbers. What this immensity truly signifies is the abundance of opportunities for life to exist elsewhere. With this many galaxies, stars, and potential planets, the probability of life forms beyond Earth becomes more plausible. Our galaxy is but a tiny speck in the cosmos, increasing the odds of other life forms existing. Secondly, the existence of exoplanets, planets outside our solar system, broadens the chances of life. But what exactly are these exoplanets? Imagine planets just like ours, but revolving around stars other than our sun. These are what we call exoplanets. Our technology has advanced to the point where we can now detect these distant worlds. As of now, we've discovered over 4,000 of them, each unique in its own way. Some are rocky like Earth, while others are gas giants like Jupiter. Some orbit close to their stars, while others lie far away. The variety is astounding, but the question that really piques our interest is, could any of these exoplanets support life? Scientists believe that given the right conditions, it's certainly possible. After all, with the right ingredients and a little bit of time, life found a way here on Earth. With billions of exoplanets, the probability of life elsewhere increases. Thirdly, water, the elixir of life, is not exclusive to Earth. The universe is a vast cosmic ocean with water found in the most unexpected places. Planets, moons, and even asteroids are known to harbor this life-sustaining substance. A prime example is Mars, our planetary neighbor, which has traces of water locked up in its polar ice caps. And then there's Europa, one of Jupiter's largest moons, speculated to have a subsurface ocean that could contain twice the amount of water as Earth's oceans combined. Even the rings of Saturn are not devoid of water. These dazzling bands are composed primarily of ice particles, which is just water in another form. And let's not forget about Enceladus, another moon of Saturn, which spews out geysers of water vapor from its south pole. Water, it seems, is not as rare as we once thought. Water's presence elsewhere means life, as we know it could exist. Fourth, the Goldilocks zone is where life could be just right. Just as Goldilocks discovered porridge that was neither too hot nor too cold, but just right, astronomers use this term to describe the habitable zone around a star. This is the region where the conditions could be just right for life as we know it. It's a region where a planet is neither too close nor too far from its star. Too close and any potential water would evaporate in the intense heat. Too far, the water would freeze in the frigid cold. But in the Goldilocks zone, the temperature is just right for water to exist in a liquid state, a condition we believe is essential for life. The fascinating part is that many exoplanets, planets beyond our solar system, reside in this zone. This presence further intensifies the tantalizing possibility of extraterrestrial life. Many exoplanets reside in this zone, furthering the possibility of extraterrestrial life. Fifth, the Drake equation estimates the number of advanced civilizations in our galaxy. Named after astronomer Frank Drake, this equation is a probabilistic argument to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. The Drake equation takes into account several factors. It considers the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, the fraction on which life actually appears, the fraction of life that evolves into intelligent beings, the length of time such civilizations release detectable signals into space, and more. It's a fascinating concept, isn't it? An attempt to put a number to the civilizations out there based on what we know and what we can guess Though it's filled with uncertainties, the Drake equation does suggest one thing with a fair degree of certainty. The Drake equation shows us that we may not be alone. Sixth, life on Earth itself, specifically extremophiles, suggests life could exist in harsh space environments. So what are extremophiles? Extremophiles are remarkable organisms that thrive in conditions considered too extreme for most life forms. We're talking about conditions like the scorching heat of volcanic vents, the frigid cold of the Arctic, or the crushing pressure of the deep sea floor. These extraordinary beings have adapted to survive where others can't, and their existence broadens our understanding of life's resilience. They have been found in places we once thought uninhabitable, like acidic lakes, radioactive waste, and even in the vacuum of space aboard the International Space Station. Their existence raises fascinating questions about the potential for life beyond Earth. If life can adapt to Earth's extremes, we must consider the possibility of life in the harsh environments of other planets and moons. If life can survive in Earth's harshest environments, why not in space? Seventh, the search for extraterrestrial intelligence, or SETI, actively looks for signs of life. This initiative, launched in the late 20th century, has been tirelessly scanning the cosmos for signals that might indicate the existence of intelligent life beyond our little blue planet. SETI's primary focus is on detecting radio signals. Why? Because we humans have been unintentionally sending out radio signals into space ever since the invention of radio. If there's an advanced civilization out there, they might be doing the same thing. But it's not just about radio signals. SETI also looks for laser light signals. These high-energy beams could be used by extraterrestrial civilizations for communication or even for propulsion of spacecrafts. While we've yet to find the smoking gun, SETI's efforts are far from futile. Each day, the search continues, with scientists around the world contributing to this grand quest. SETI's quest reminds us that the search for extraterrestrial life is ongoing. Scene script. Eighth, the Fermi paradox poses an interesting question. Where is everybody? Let's delve into this paradox, named after physicist Enrico Fermi. The Fermi paradox is an intriguing contradiction. It points out a discrepancy between the high probability of extraterrestrial life, given the vast number of stars and planets in the universe, and our lack of contact or evidence for such civilizations. You see, if there are a multitude of advanced civilizations in the galaxy, then it would be expected that we would have already had some form of contact with them, but we haven't. This is the enigma that is the Fermi paradox. Various solutions have been proposed, ranging from the idea that intelligent life is extremely rare or short-lived, to the notion that advanced civilizations are avoiding us. The Fermi paradox reminds us that the universe is vast, and we may not have found our galactic neighbors just yet. Ninth, the future of space exploration may bring us closer to answering the question of extraterrestrial life. As we gaze into the cosmos, we can't help but wonder what lies beyond our own solar system. What secrets are waiting for us to uncover? One of the most exciting prospects is the potential discovery of life on other planets. And with the upcoming missions and cutting-edge technologies, we might just be on the cusp of such a discovery. Consider the James Webb Space Telescope. This marvel of modern engineering is set to launch in the near future, and it promises to revolutionize our understanding of the universe. With its unparalleled sensitivity, it could detect the faintest signs of life on distant exoplanets, potentially reshaping our perception of our place in the cosmos. Then there's the exciting prospect of Mars rovers. These robotic explorers have been tirelessly trudging across the red planet, probing its surface for signs of past or present life. They are our eyes and ears on Mars, and every new discovery they make brings us one step closer to answering the age-old question, are we alone in the universe? The future of space exploration is a thrilling frontier filled with endless possibilities and unanswered questions. Each new mission, each technological advancement brings us closer to uncovering the secrets of the cosmos. As we continue to explore, we inch closer to potentially discovering life beyond Earth. Finally, we come to the end of our journey through space. We've traversed the overwhelming vastness of the cosmos, considering its incomprehensible scale. We've explored the existence of exoplanets, those celestial bodies orbiting stars beyond our own sun. We've delved into the surprising presence of water in space, a vital ingredient for life as we know it. We've looked at the Goldilocks zone, that perfect just right distance from a star, where conditions might allow life to flourish. We've pondered the Drake equation, that mathematical estimation of the potential for intelligent life elsewhere in the universe. We've examined extremophiles, organisms on Earth that thrive in conditions we once thought uninhabitable, giving us hope for life in the harshest corners of the cosmos. We've discussed the search for extraterrestrial intelligence, or SETI, and the perplexing Fermi paradox. We've also envisioned the future of space exploration, a fascinating realm of infinite possibilities. While we may not have definitive answers, the possibility of extraterrestrial life continues to fascinate us. Keep looking up, wondering and asking, what else could be out there?